In previous lecture, I discussed product rule of basic counting. Today, I will discuss sum rule. If events are independent, then we can use the product rule. If events are dependent, then we'll use the sum rule. If a task can be done either in one of the n1 way or one of the n2 way, where none of the set of n1 way is the same as any of the set of n2 way. n1 and n2 both are different. Either we can choose n1 or we can choose n2. Then there are n1 plus n2 way to do the task. Let's see one example. Example 6. A student can choose a computer project from one of the three lists. The three lists contain 23, 15 and 19 possible projects respectively. No project is on more than one list. How many possible projects are there to choose from? So either the student can choose 23 or 15 or 19. Means there are three lists. In first list there are 23 projects. In second list there are 15 projects. In third list there are 19 projects. Either he can choose from this 23 or this 15 or this 19. So how many way the student can choose the project? It's 23 plus 15 plus 19. It is 57 way. The student can choose a project from this three list in 57 way. Let's see another example. Example 7. A pair of dice were tossed. Number of way we get total 7 or 8 each. So we have two dice. This is a dice. Dice have 6 faces. Now it is asking how many number of way we can get either 7 or 8. Sum will be 7 or 8. So 7 can be 1, 6, 2, 5, 3, 4, 4, 3, then 5, 2, 6, 1. So we can get 7 in 6 way. So 1 from one dice, 6 from another dice. So total sum is 7. Then 8 we can get from 2 dice by 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. 5 ways. So total number of ways equals to 6 plus 5, it's 11 way. Now if 2 dice are identical, okay, in case of identical 3, 4 and 4, 3 will be same. So we can get 7 in 3 way. If 2 dice are identical, it's 1, 6, 2, 5, 3, 4. As 3, 4 is same as 4, 3. 2, 5 is same as 5, 2. 1, 6 is same as 6, 1. So total 3 way if 2 dice are identical. Now 8 also can get in 3 way. 2, 6, 3, 5, 4, 4. So total number of way equals to 3 plus 3, 6 way if 2 dice are identical. So based on question, if it's distinguished, then 11. If it's identical, then 6. Next, example 8. How many integers between 10 power 5 and 10 power 6 have no digits other than 0, 2, 5, 8? So numbers are in between 10 power 5 to 10 power 6. Means it contains 6 digit. Okay. And that digit should be 0, 2, 5, 8. 0 cannot be in first place, as if 0 will be first place, it will be not in this range 10 power 5 to 10 power 6. So in first place there can be 2, 5, 8. In second place it can be 0, 2, 5, 8. In third place it can be 0, 2, 5, 8, 0, 2, 5, 8. First place we can choose in 3 way. Second place we can choose in 4 way. Third place 4 way. Fourth place 4 way. Fifth place 4 way. Sixth place 4 way. So number of integers between 10 power 5 and 10 power 6 have no digits other than 0, 2, 5, 8 equals to multiplication of all. 3 multiplied 4 multiplied 4 multiplied 4 multiplied 4 multiplied 4. It's equals to 3072. So there are 3072 integers between 10 power 5 and 10 power 6 having no digits other than 0, 2, 5, 8. In today's lecture, I discussed sum rule, then 2 examples of sum rule, 1 example of product rule. In next lecture, I will discuss some more examples of both sum rule and product rule. If this lecture is helpful for you, please like, share and subscribe. Thank you.